In the late 1990s, the world of astrophysics was shaken to its core. Scientists had long known that the universe was expanding, a remnant of the Big Bang. But the prevailing wisdom suggested this expansion would be slowing down. Gravity, after all, should be pulling everything back together. Then came the bombshell. Two independent teams of astronomers, both studying distant supernovae, reached a shocking conclusion. The expansion of the universe wasn't slowing down. It was speeding up. These exploding stars, called Type Ia supernovae, became cosmic mile markers. They are incredibly bright, allowing astronomers to see them across vast distances. More importantly, they always explode with the same intrinsic brightness. This means their apparent brightness, how bright they appear from Earth, tells us exactly how far away they are. By carefully measuring the redshift and brightness of these supernovae, the teams found something astonishing. The most distant supernovae, those that exploded when the universe was much younger, were fainter than expected. This meant they were farther away than our models predicted. The universe wasn't just expanding, it was expanding at an accelerating rate. This discovery sent shockwaves through the scientific community. It challenged our fundamental understanding of the universe and hinted at a mysterious force driving this acceleration. Something was missing from our cosmic recipe, something powerful enough to counteract the pull of gravity on a cosmic scale. That something, physicists believe, is dark energy. Dark energy is one of the most profound mysteries in modern science. It accounts for roughly 68% of the universe's energy density. Scientists believe it's responsible for the accelerating expansion of the universe. Imagine the universe as a loaf of raisin bread dough rising in the oven. As the dough expands, the raisins, representing galaxies, move further apart. This is analogous to the effect of dark energy. We don't know exactly what dark energy is, but physicists have a few leading theories. One possibility is that it's a property of space itself, a kind of anti-gravity that pushes things apart. This idea is linked to the cosmological constant, a term Albert Einstein first introduced in his theory of general relativity. But the discovery of the accelerating universe brought it back into the spotlight. Whatever its true nature, dark energy's influence is undeniable. It's shaping the evolution of the cosmos on the grandest scales. The expansion of the universe is often visualized as an explosion, with galaxies flying away from a central point. However, this analogy is misleading. The expansion of the universe is not an explosion through space. It's the stretching of space itself. Imagine a balloon with dots drawn on its surface. As you inflate the balloon, the dots move farther apart. The dots themselves aren't moving across the surface. Instead, the space between them is expanding. This is similar to what's happening in our universe. The galaxies are not flying through space like rockets. They're embedded in space, and it's the fabric of space itself that's stretching, carrying the galaxies along for the ride. This means that the expansion is happening everywhere, at every point in the universe. This stretching of space has a profound implication. The farther away a galaxy is from us, the faster it appears to be receding. This is because there is more space between us and the distant galaxy, so there is more space that's stretching and contributing to its apparent velocity. This brings us to Hubble's law, a cornerstone of modern cosmology. Section 4. Hubble's Law, charting the universe's accelerating growth. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. He observed that the farther away a galaxy is from us, the faster it is moving away from us. This relationship, now known as Hubble's Law, provided the first observational evidence for an expanding universe. Hubble's Law can be written as V equals h0d, where v is the recession velocity of the galaxy, how fast it's moving away from us. D is the distance to the galaxy. h0 is Hubble's constant, a parameter that describes the current rate of cosmic expansion. This simple equation is incredibly profound. It tells us that the universe is not static, it's dynamic and evolving, and the rate of this expansion is determined by Hubble's constant. The discovery of the accelerating universe means that Hubble's law needs a slight modification. The relationship between distance and velocity is not perfectly linear. At very large distances, the expansion rate is actually increasing, driven by dark energy. By measuring the recession velocities and distances of distant galaxies, astronomers can determine the value of Hubble's constant and study the expansion history of the universe. These measurements are crucial for understanding the nature of dark energy and its influence on the evolution of the cosmos. Section 5. The Fate of the Cosmos. From Big Freeze to Big Rip. The accelerating expansion of the universe raises profound questions about the fate of the cosmos. What will happen to the universe in the distant future? Will it continue expanding forever, or will it eventually collapse upon itself? The answer to this question depends largely on the nature of dark energy. If dark energy behaves like a cosmological constant, remaining constant over time, then the universe is headed towards a big freeze. In this scenario, the universe will continue to expand and cool indefinitely. Galaxies will drift farther and farther apart, and eventually, star formation will cease. The universe will become a vast, cold, and desolate place. However, if dark energy is not constant, if it increases over time, then a more dramatic fate awaits the universe: the Big Rip. In this scenario, the accelerating expansion will become so extreme that it will eventually overcome all other forces, including gravity. Galaxies will be torn apart, followed by stars, planets, and even atoms themselves. The universe will end in a cataclysmic shredding of space-time. Other scenarios are also possible, including a cyclical model where the universe expands and contracts in an endless cycle of big bangs and big crunches. The fate of the universe remains one of the most fundamental unanswered questions in cosmology. Section 6. Unraveling the Mysteries: The Quest to Understand Dark Energy. The discovery of the accelerating universe and the enigmatic nature of dark energy have ignited a new era of research in cosmology. Scientists around the world are working tirelessly to understand this mysterious force and its implications for the universe. One of the most promising avenues of research involves measuring the expansion history of the universe with ever-increasing precision. By studying distant supernovae, galaxies, and other cosmic objects, astronomers can track how the expansion rate has changed over time. These measurements can help us determine whether dark energy is truly constant or whether it varies over time. This, in turn, will provide crucial clues about the nature of dark energy and its role in the universe. New telescopes and instruments, both on the ground and in space, are being designed and built specifically to study dark energy. The James Webb Space Telescope, launched in 2021, is providing unprecedented views of the distant universe, allowing astronomers to study the earliest galaxies and probe the nature of dark energy. Another ambitious project is the Dark Energy Survey, which is using a powerful camera on a telescope in Chile to map hundreds of millions of galaxies and measure their distances and redshifts. By studying the distribution and properties of these galaxies, astronomers can learn more about the evolution of the universe and the influence of dark energy. Section 7. Cosmic Expansion: A Journey into the Unknown. The accelerating expansion of the universe is one of the most profound discoveries in the history of science. It has fundamentally altered our understanding of the cosmos and raised profound questions about the nature of space, time, and the fate of the universe itself. Dark energy, the mysterious force driving this acceleration, remains one of the greatest enigmas in modern physics. The quest to understand dark energy is a journey into the unknown. a journey that is pushing the boundaries of human knowledge and ingenuity. By studying the expansion history of the universe, developing new theoretical models, and building ever more powerful telescopes, we are gradually piecing together the puzzle of dark energy and its role in the cosmic drama. The accelerating universe is a reminder that we live in a dynamic and evolving cosmos, a universe full of wonders and mysteries yet to be unveiled. The journey to understand our universe is far from over. In fact, it's just beginning. Like and subscribe to start your journey today.